Hi there. In this video, I'm going to describe and demonstrate a, a testing instrument that is a multi-component tester. This is a device that can be used to test different type of electronic components, including many active and passive devices. So this is a very useful instrument for all those who are into electronics DIY or home brewing and building electronic circuits. So um, this particular tester, it's called the LCR-TC, LCR-T4. So this is a very very handy, uh, uh, very very handy device, uh, which can be used instead of very costly equipments. So it gives the basic readings and somewhat accurate readings of all the different electronic components. And this is a new device here, and this one is an old one which I had been using previously. This is somewhat okay, but the accuracy level seems to be a little low. So instead of that, I bought a new one. This is the new device, LCR T4 T4 multi-component tester. So going to the different parts of this device, it has uh, the display section, which is an LCD type of display here, which shows all the components, the electrical points of the component, and certain parameters that are needed to be tested. It is shown here on this display. And we also have the component socket or slot socket, where you have to insert the component leads into these sockets, and lock it using this latch, I mean the key here. And thereby you can lock in these components on the specific leads, the sockets here, and take the readings using this device. This is a socket. This is a component placement socket. Similar is it's shown here, which is a SMD type of measurement platform here, where you can insert any SMD devices onto it and measure the values. After insertion, you have to press the this button so that it will test the component, the value of the components inside. So this is how it is, and it is powered by a 9-volt this type of project battery, and I have made it. I have given a DC jack here so that I can insert DC socket so that I can insert this DC jack inside. So this is the basic details about the this device. So this is the back side of the device. I have inserted this socket, DC socket here, and this unit can be placed inside a acrylic acrylic unit. This box, this can also be bought separately, so that it can be placed inside this box to make it to protect it from breakage or destruction. So this is about it, and So we also have this test leads, the testing leads or test probes, where one side of it has some pins where you can insert in here into the socket here and lock it. And the other side has certain probe points where you can insert divide the legs of each component here like this. So by locking this using these test probes, you can measure this value, measure the value of these components by locking the leads of this component like this. So this is how it is working. So we will just briefly go through the different measuring different values of different components. So initially we'll test this. This is a resistor. We'll see what the value is by you can just introduce into the socket by inserting in like this and locking it. Then it shows 99.76 kilo. So it is around 100 kilo ohm, 100k resistor. So it's reading very near value 99.76 kilo ohm. So this is a 100 kilo ohm resistor. And the slots here we have the 1, 2, 3 and slots. The same thing is repeated here also, and these specific slots has the first lead that is repeated here. The first 1, 2 and 3 are different, and these are all slots are connected internally together. That is, these 4 slots have the one connected internally with this first slot, and 2 and 3 has different sections. So this is internally connected between these 2 slots, 1 and 1, 2 and 2, 3 and 3, 1 and 1, 1 and 1, 1 and 1 and 1 and 1. So this is how it is internally connected. We'll just test another resistor here. You can insert it like this and test. It shows 9806 ohm. So it is a 10 kilo ohm resistor. It's a 10 kilo ohm resistor. This shows a 989.5 ohm. This is almost near to 1 kilo ohm. So this is a 1K resistor, and we just test some capacitors here. This is a 47.18 NF, that is 0.047 microfarad, 0.047 microfarad. So its written is 0.047 microfarad. We'll test this. You can place it like this also, 1 and 2 and 1 like this. You can see the initial voltage reading also. This is a 22.84 NF, that is a 0.02 microfarad, 0.02 microfarad. This is a 102.9 NF, that is a 0.1 microfarad. It is a 0.1 microfarad capacitor. It must be written on it. It is a 0.1 microfarad capacitor. It shows 979.9 pf. It's a 0.001 microfarad or 1 nanofarad. That is the 1 nanofarad capacitance. This is shown as 979. It's almost near to 1000 pf or 1 nanofarad. Okay. So we'll test this one. This is 10.239 nanofarad. This is very near to 10 nanofarad or 0.01 microfarad. So we have measured all the resistances and capacitance. Then we have the certain PF values here. We'll just go through the PF values. It's 15.29 PF. So it's almost similar. The value is similar. It's 15 PF. So it is shown very near value, 15.29 PF, very near to very close value. So this is a 3 PF value, 3.3 PF. So below 5 PF it doesn't read correctly. So it is not showing. It is showing as unknown value. So values below 5 PF is not correctly read, or it is not read clearly. And we'll just check this one. This is also a very low value. It is a 6 point. It's shown as 6.43. Actually, this is a 6.8 PF. So it's very near to the 6.43 PF. Very close value here. This is a 33 picofarad, 33 PF. It's actually a 33 PF. So it is very is accurate value is showing. And 22.54 PF. It's a 22 PF value. It's a 22 PF value. And we'll just go through some inductors here. It's showing 0.1 microhenry. It's 0.1 microhenry. It's 0.1 microhenry. This is 10.32 microhenry. It also shows a ohmic reading here because it has a lot of turns, and there is a resistance inside the inductor. So that resistance is also shown here along with the inductance value, that is 10.32 microhenry. This value is 1 microhenry. It's 1 microhenry along with 4.6 ohm. It has a resistance value also, that is 4.6 ohm. So these are the inductances. And one more inductance here. It is like a resistor, but it has a reading like the resistor. And shows 0.06 micro Henry and 1.3 ohm. So it's very low value inductor. Now we'll move on to the diode here. This is showing as a diode. It gives the reading of a diode that is connected between 1 and 2 pins with a forward voltage of 653 millivolt. With this is a forward voltage, that is the voltage that is needed to the conduct this diode, and it also shows the capacitor, the junction capacitance, that is 11 pf. So those two values are shown here. This is just a rectifier diode. Now we'll move to a signal diode. This is a signal diode that is also showing 680 millivolts. This is forward voltage, and the capacitance is just 1 pf, very small pf value. This is a LED. It's also shown as a diode with forward voltage of 1.992 volt and 3 pf capacitance between the junction. Junction capacitance is 3 pf. The forward voltage is 1.92 volts. It also the LED also blinks when this is tested. This shows forward voltage of 1.89 volt and 3 pf. So that is over, and we'll move to the transistors. Here we are testing one transistor. This is an NPN transistor. You can see the different leads. You can identify the leads by noting the leads and the numbers that the leads have been inserted. So you can identify the leads and also the gain, that is the beta value, that is HFE value, that is a gain value 539, and the forward voltage, that is a base emitter forward voltage of 789 millivolt. So this is these are the two parameters and the different component, the lead identification, that is, so this is an NPN transistor. So this is an NPN transistor. This is an N-channel Mosfet. This is an N-channel Mosfet with the junction capacitance, the gate capacitance of 47 pf, and the threshold voltage of 1.6 volts. This is a PNP transistor with the HFE value, the gain value 320 gain, and the forward voltage of 849 millivolt. The leads are also shown here, PNP. This is an NPN transistor with the HFE 202 and the forward voltage of 682 millivolt. NPN transistor. This is actually a FET. Actually, it's an FET, but it shows as a thyristor. This is a BFW10 transistor, but it shows as a thyristor because it also has the gate lead and the threshold voltage and gate voltage. PNP transistor. So these are the different testing. We can just test a few. This is an VNP transistor. This is the way you can connect the leads for higher bigger grade leads. We used to connect it like this. For a bigger transistor power transistors, we can connect using this test lead like this, and it shows it's a PNP transistor. This is an N-channel Mosfet with the gate capacitance and the threshold voltage that is given. The internal diode also is shown here. All the lead identification is also given. So this is how you can test different components using this tester. So thank you for watching, and 73s.